today you're going to see pictures. I don't like PowerPoint. I've been to too many PowerPoints where guys put the slide up on the screen and then they read it to you. And it's a total snooze. And what we're going to talk about today is best practices in roofing and siding. This is not geared to roofers and siders. It's not technically the way things are done. My assumption is that you guys are GCs, you're builders, you're remodelers. And so you don't really need to know the fine nuts and bolts of how to put in a louver or a skylight. What you need to know is where the pitfalls are, the things you need to know as a general contractor overseeing your subcontractors. So that's the scope of what we're going to talk about today. Put this scene up, nice lake scene. And the reason that's there is because we're talking about water. Everybody loves water. You can play in it, you can go to a water park, it's great. However, what you need to keep in mind is that water is also Mother Nature's composting agent. And if water gets into your building, that's what it's going to do. Eventually, it will turn your building into compost. Good example. Guys are hunters, fishermen, sportsmen. Let's see, you've got a nice Queen Anne desk, 300 years old. Keep it in the house, warm, dry. It'll live another 300 years. Put it outside for a few weeks. Put it in the woods for a few months. What happens? The deterioration sets in. And what water does, it isn't the water itself that will get you. It's the life that it supports. Water will start the growth of mold and mildew and lichen and fungus. And as you're going to see from our pictures, it's in buildings. And it's in buildings because the roofer, sider, general contractor did not coordinate to keep the water out. So that's what we're going to talk about today. You know, you can live for, what, a month without food, 3 days without water. But you're going to see what happens when a very small amount of water is allowed to penetrate a building for a period of time. Let's just start looking at some of these pictures. We didn't make any of this up. This is all from our archives. My first step on a roof was in 1971. I went into business in 1981, so I've been in the roofing siding business for over 30 years. And we get called out. We get called out to look at this sort of thing and to fix it. My goal here is for your projects that this doesn't happen in the first place. If you look here, notice the icicles are coming right out of the vent. See that? It isn't just cascading over the side, and over here, it's actually coming out from in between the siding. Now, if it's coming out from between the siding, what do you think is going on inside that wall cavity? Well, you're going to see. You're going to see, so we won't keep you in suspense. Here we pulled the plywood off the underside of a soffit. Not only was the water on the outside, you can see it's a canted soffit, but it was filling up with water. This is a chimney on a condo project that we were called out to inspect and repair. And now I'm going to use the big club in this business, the word lawsuit. That's one of 40 chimneys in this development, and they all look exactly like that. There's a couple of things. We're going to come back and look closer at this as why this happened. But notice on this corner that the black goes all the way up. The rot's pretty significant. You can see here that the OSB is already completely gone. This building's about 10 years old. A little close-up so you can get a look at that. That's what I was saying about Mother Nature's compost, because that's what it's doing. It's destroying the material This is not the same chimney. This is a different one. But the amount of black behind there is just incredible. This is a different building. We're going to come back and revisit these pictures. This is for purposes of illustration. On this house, this was amazing when we started taking this apart. This is I went backwards. This is EIFS. You saw it up in the corner. This won't back up. Applied directly over OSB. No drainage plane, no flashing, no nothing. This is the result of that. Yeah. How would you like that to be your project? How'd you like to sit in a witness stand and face the lawyers looking at that picture? It's not good. So, in preparing for this, rather than focusing on technical things, we're really going to talk about roofing, major problems that can be avoided, and in siding, keeping the water out. That's the thrust of this. When I got started, way back when, there were two things that we didn't have that we have now that are total game changers. Total game changers when used correctly. And those are ice and water shield. Preferably, I'm a fan of Grace. They were the original. They're still the best. They're also the most expensive by a mile. But it is the best product. And used correctly, which we will get to, it can save your ass. That's all there is to it. The same thing with Tyvek. Tyvek is another innovation that does not go back 30 years. And the problem with those chimneys that you saw is the builder's thinking, this is a chimney. Why do I need to keep the air out? Why do I need an air infiltration barrier? I don't. Therefore, I'm not going to use it. True. He didn't need to keep the air out. But he did need to keep the water out. And that's the other side of Tyvek, is that it acts, and Typar, I'm not trying to promote DuPont, but that it keeps the water out when properly installed. Talking about roofing, which is going to be the first part of this, I knew that I didn't need to talk to you about how to put in a vent, how to put in a skylight, how to cut in a valley. You don't need to know all that. You need your roofing contractor to know that. But this speaks to a bigger issue. This is partially a design issue. Builders, remodelers, GCs, you get your hands dirty in design. And when you have, we see this a lot, when you have a situation like this where you have a cricket, which is what that is, a little pan in there, you're feeding, the upshot is that a lot of water from all around here all goes right through this pan. The only way out is right there. What you don't think of is that you can make a pile of water. You think you pour out water, it flows out, it's flat. Not true. You can make a pile of water. Think of Katrina. Think of a tsunami. Okay, so now, if you get an inch an hour rain, that's probably 3,000 or 4,000 gallons of water on the whole roof, not on just this area. But all the water that falls here has only one way out, and it's right there. And it's small. And it gets compounded by this. Now, the owner can't see that from the ground. He doesn't know that's there. All right, so now all the water's trying to get out, and it can't. So what does it do? It piles up. It gets deeper. So along this edge here, which is behind the leaves, let's say your carpenters are really meticulous, so they nail that siding nice and close to the edge right there. They don't want that to come off. And your roofer, same thing, along this edge. He's got nails down there nice and close, don't want them shingles to come off. And the water piles up. It's in the building. It comes through those nail holes, it gets up between the shingles, down at this corner here, and you've got a nasty leak. Solution? Ice and water shield. When we do pans like this, we don't give our customers a choice. It's the only way we'll do it. That entire area is covered in ice and water shield first. Then we build the pan, and when we build the pan, these legs on the side here, 4 inches is not enough. It's enough up here, but it's not enough down there. Same thing on this side. That leg of that pan, that needs to be tall, 12, 18 inches sometimes. Then after the pan's in, you wrap it in ice and water shield again, and your installers know you can't put nails down there. Even with the ice and water shield, you don't put nails down there in what's below what we would call the pond line, where the water's going to build up. If you do that way, good things happen. Now this pan is better. It's not great, but it is better. And the reason it's better is because it doesn't break in the middle. It's a one-way pan. The problem with this, and this is something, again, you're a modeler at GC, you draw plans, you have input, right? Oop. Dave, can you back me up? I keep hitting that. Right here, the pan really should not come to a point. Okay, the natural inclination of the carpenters who build this, you bring that right to the corner, you bring it to a point. What we found, the hard way, is that if right here you build a mouth on this thing so that it comes down to 8 inches or 6 inches, that doesn't seem like much, but 6 inches is way more than none. So now you're leaving a path. You're leaving a path for the water to get out. The other thing that I want to comment right here, and we'll get to this later, is along the sidewall, okay? A lot of times, we see it more on a tin wall. The roof goes on, the step shingles are in, and carpenters, being what they are, they think tight is good. Make it fit tight. And so they take the siding and they cut it right up tight to the roof. Wrong. The siding should never touch the roof. Your corner boards should never touch the roof. When the water passes through there and that's touching the roof, that butt joint, that bottom edge will stay wet. It will stay wet for a long, long time. All right, move forward. Ice. Wisconsin. Now we didn't have a bad winter this last year, but we've had some. Is there anybody that does not understand how this works? If you've been in business in Wisconsin for more than a few years, you've had to deal with this. And we're going to talk about the anatomy of an ice dam. I just thought that was a cool picture. There's that one again, ice coming out. Now there's multiple causes to this. There's multiple solutions. That one again. What causes ice dams? Now we could actually, part of this is, it's not that it's incorrect, it's just incomplete. We could do a whole day just on ice dams. Basically what happens is you have a heated space, that's where you live, and you have a cold space on the outside. And some of this heat gets to this snow, which creates liquid that runs down until it gets to about here. And then what happens? No more heat. It's outside the warm line of the house, exactly. No more heat. So it gets down in here, and actually what we've learned over time is that ice dams actually start here at the bottom, and they work their way backwards, and they build up. The other thing that we learned is when you go to take them out, as an ice dam forms, there's a layer of water and it freezes, another layer of water and it freezes, another layer of water and it freezes. So essentially that ice dam is laminated. That is the hardest ice you can ever run into. We actually resorted to chainsaws to cut into ice to get it off of buildings. Not all the way down to the roof, of course. Now what's missing here from this picture, let's talk a little bit about this, about how to prevent this from happening. And these are all different stories for a different day. Insulation. If your insulation is really good right in here and here and here, all right, now you've reduced the amount of heat that escapes into the attic. In a perfect world, your attic temperature should be the same as the outside temperature. If it's 100 degrees outside, attic should be 100. If it's 0 outside, your attic should be 0. That's in a perfect world. That never happens. All right? So, insulation. Now, Some heat gets past the insulation. What they're not showing here is your ventilation system. There will be ventilation in the soffit, a path through here, ridge vent or pot vents up at the top, and any stray heat that gets into your attic gets carried away by your ventilation. That helps too, okay? So now you're doing your best to get rid of that heat. The third thing that's come up in the last few years that wasn't a big deal before, but now is air sealing. And it's been figured out that where there are holes, can lights, light fixtures, even electricians drill through the top plate to run wiring up into the attic, all of those perforations, those holes, let warm air seep into the attic. So now you've got convection, or not convection, but conduction, the radiated heat loss into the attic, but you're also sending just warm air into the attic. Notorious culprits, bath fans that become disconnected in the attic. Now they're disconnected in the attic, all that warm moist air from the bathroom is being pumped where? Straight into the attic. So now you have heat and you have moisture in the attic, whole nother story. All right. What we've discovered down here, notice there's no gutters on this drawing, is that this ice dam will actually start forming in the bottom of the gutter, okay? That's important because these things that we've talked about are ways to mitigate ice dams, to minimize them. Ice and water shield is a barrier, and that goes in right here along the bottom of the roof. Grace Ice and Water Shield has a rubberized core. It's gooey in the middle. The best way to describe it is like a puncture-proof tire. So that goes on along your gutter lines, and when your roofers come along and nail through it, it seals around all the nails, and it really works. So now, you've got a barrier right here. That barrier could be as high as 6 feet, depending on your slope, size of your soffits, 3 to 6 feet. You want to be up above the warm line. But you've prevented the water. You can have all ice you want on the roof. If your ice and water shield is good, who cares? It can live up there forever. It can melt in the spring. The problem that we've discovered, and I hope this shows up good on the screen, is right here. When Ice and Water Shield first came out, what everybody did was they substituted it for the first row of felt, or the second row of felt. Lay it along the bottom, gutter apron either went underneath or on top, but the Ice and Water Shield was rolled along the bottom, and you had protection from the top of your baseboard up the roof. And that worked, almost. I'm going to go to the next one. I hope you can see this. This is a little crude, but over here, that's the Ice and Water Shield, and that's your gutter apron, okay? And what we found was that when the ice, we're using red for ice because it shows up, when the ice started to build up in the bottom of the gutter, and the water was coming down on top of it, what would happen? The water crawled up behind the gutter, over the top of the baseboard, and bam, it was in your soffit. I have Ice and Water Shield on my house. I got water in my soffits. What's wrong? That is what was wrong. And it didn't matter if you put the apron on top of the membrane or underneath it. Either way, there's a little path here. Solution? Over here, this line represents Ice and Water Shield going right over the side of the building. Drop down 2-3 inches onto the baseboard. So now it's continuous. You can put your apron over it. You can put your gutter over it. Gutter can fill up with ice right here. Fill up all it wants. It cannot get through this gap. Therefore, it stays out of the soffit. And it looks something like that. I went out to a site, took this picture. This apron is on top of the Ice and Water Shield. This particular product is Weather Watch from GAF. Notice that the Ice and Water Shield is hanging out below the apron. And if you're a GC, a builder, remodeler, and you go on your site, that's what you want to see. Trust me. There's no added cost. You're already paying for the Ice and Water Shield. It's just a matter of how it goes on. Yes, sir?
So on a remodel, when you're part of the job required replacing rust and roof,
Yep.
all gutters are coming off,
Okay.
correct?
Depends if you're just doing part of it or all of it.
Well, no, the job's going to entail the whole roof being.
Oh, yeah. Okay. Yes. Strip it down to bare.
All gutters have to below
Yes.
the intersection of where the gutter is gonna
Yep.
go back.
And there was some thought that high back gutters made a difference. Some older homes back in the day, we used high back steel was the way it was done, always put on by the HVAC guys. Doesn't matter. It'll still crawl up, get over the top, and come back in. So when we talk about best practice, in our estimation, my estimation, this is the best practice. Yes?
It doesn't necessarily have to come down below the gutter apron as long as it wraps the edge of the plywood?
Correct. Well, and that creates another issue. In our operation, our gutters are put on by our own guys. We have our own gutter crew. So they want to see that because they want to be on top of it to slide the gutter in. And if the ice and water shield is up behind the apron, they can't see it, it might not be tight, they go to put the gutter in there, and they struggle with it. So we actually tell our guys, you can let it run long. I mean, if you're in a bad spot, you're hanging out, you know, life is on the line, let it run long. The gutter guys will trim it, but you can't trim what's not there. Now, this brings up another issue, talking best practices. See these little corners right here? There's a little return on the back of this with a little hip. And so there's a corner right there. And it really does no good at all to go to all this trouble if you don't close that, like that. So not only do they have to let it hang low, but you have to wrap it around the corner. How did we learn that? We learned that the hard way. All the ice and water shield's on, it's all good, you know, gutters are on. Ice, they fill up with ice under certain situations, and it would crawl right up here. And look what you got right there. You got a seam in your faceboard, you got a corner in your soffit. You know the roof plywood doesn't come right down exactly to the faceboard, it's close, and water would come in. So an outside corner and an inside corner, same way, needs to be closed. So, if you do all that, should be good, right? But it isn't just one thing. It's part of a system. You do your insulation right, you get your ventilation right, do your air sealing, do this. These houses are bulletproof. We never go back, any reason at all, for ice on them. Never, never, never. Yes, sir?
Proper height for the ice and water shield is so you get above the walls that you're covering all the cold.
Right. I think in their specs they call for 24 inches above the warm wall. So and we're going to show one later, an arts and crafts style home, really big soffits. You know, if you have a 3-foot soffit, you got to go 6 feet ice and water shield. You know, if you've got a narrow soffit, a lot of pitch to it, you don't have to. In that case I showed you before, actually backed it up 2 slots, Dave. That's a sunroom. That's an unheated space. And yet, the builder spec, ice and water shield everywhere. So they're not short sheeting the bed here at all. So, all right, let's talk about this. We're going to shift gears now from roofing to siding. These chimneys. There's a whole lot that's wrong here, besides the fact that there's not just Tyvek on them. If you look right up here, okay, see that little spot right there? You see the corner? That's a back flashing on the back of that chimney, which is just a piece of metal that's bent in reverse, goes up the back of the chimney. And that's supposed to catch the water that's coming down the roof right here and get to right there. The builder put in this little double face piece here, which we were able to save so we didn't have to break into the soffit right here. Save the association some money by doing that. And what they did is right here, there's a little piece of drip sill. Everybody know what drip sill is? It's a Z-shaped piece of metal that goes on top of windows and doors. Well, that's what's there. All right? Problem. Water comes down the roof and it hits the chimney, square on. And now the water has to make a decision. Am I going to go out that way to the right? Or am I going to go this way to the left? And it's a horse piece. Nobody knows where it's going to go. I can tell you where a lot of this water went. So what happens? Right there, that little piece of drip sill is acting like a little gutter. And it's funneling the water right behind the corner board right there. Now, this, again, a roof, 3,000, 4,000 gallons of water in rainfall. This might have taken a cupful each time it rained. Maybe a quart. That's all it takes. That's all it takes. Because unlike an attic you have airflow. An attic gets warm in the summer, it gets up to 130, 140 degrees. All the water boils off, goes out through the vents, and it heals itself. It dries if it's a small leak. Wall cavities, Once the water's in, it's there for life. So we had this issue right here. Now we'll get to this. Now look up here. On this side, it's pretty dry going up from here. Same thing on this corner. This one's black all the way up. Why would that be? Our best guess is more than a guess. But this chimney head up here isn't level. They never are. And this particular one is tilted right here. So it's dumping its water, which is only 24 inches by maybe 4 feet, 5 feet, something like that. It's all coming right down here, okay? And this one actually is worse than the one that had the water feed from going up the roof. I mean, look at the rot. Didn't smell too good either. And, of course, gravity being what it is, takes it all the way down. All the way down. Did I mention there were 40 of these? Puts the cost of repair easily north of 100 grand. Is an owners association going to sue their builder for 100 grand? Yes. Okay. I did not show the pictures of restoring all the carpentry because that wasn't really part of what we're talking about here. But again, this is what they look like. I was actually going to come back to this up here. Again, concentrate on that little area right there because we're going to come back to that because that was critical to this. All right. Reframing's been done. All the rotted wood's been replaced. Chimney's wrapped in Tyvek for a drainage plane. Now right up here, and I hope this shows up, right there, what's been done is instead of a little drip sill that could dump behind the faceboard, this particular piece of flashing turns and goes up alongside the faceboard. So now, when water comes down the roof, gets to the back flashing over here, there's no way out except to spill over the front, which is fine. You always want to put the water on the face of the material. Put water behind the material, you're done. You have to keep in mind that while each piece of siding might be waterproof, as an assembly, it's only water resistant. It's not waterproof. So the old chimney, right here, alongside all these corner boards, relied on caulk to keep the water out. Not that there's anything wrong with caulk. Makes things look pretty. But in a condo situation, caulk on a cedar corner board, how long does it last on a sunny side? 3 to 5 years maybe. Usually really good stuff, Vulcam TX1, best stuff you can find. I don't know what your preference is. It needs maintenance. These don't get maintenance. Even owner occupied, when it's up high like that, they don't go up there to fix that. So it's really not a good system. And currently, the code calls for a drainage plane. Didn't used to, but now it does. So up in here, that's been changed to shut that water off. Now, this chimney, and I'm using this for reference, you can see this on the chimney, it's cedar siding. The issue doesn't start way up here. Right even here, look what's happening to the paint, okay? Think this has been maintained? If the paint hasn't maintained, you think the caulk's been maintained? So down here, you've got this rot, all right? I think I have a closer look. There we go. That's caulk failure. That's all it is. It's caulk failure. But the caulk was being asked to do something it shouldn't have to do, which is keep the water out, which it really doesn't do, as you can see over time. And how bad is it? That's the lower corner. Pretty significant. So the message is, keep the water out from behind the siding. Tyvek's cheap. What, $100, $110 a roll, something like that? Tyvek is cheap. Lawyers are not. Now I'll come back to this house. This was such a nightmare. You had to see it in person to believe it. But if you look right up here, you can see that ephes, early generation, but even so, is right on the OSB. Now, what builder would do that? What ephes guy would do that? They know their product. Was it at the time they thought that ephes was waterproof, not water resistant? Because now the rules about putting ephes on are much different. You rely on the drainage plane. You have to flash things. All right. How are we doing for time? What time is it? Okay. I know you guys, lunch is next, so we won't run long.
Quick question.
Sure.
How old of a home is that?
10 years.
Who's responsible for that?
Well, it's currently in litigation. The owners had 2 different builders. I don't know the whole history of it. They got into the project. They canned the first guy, brought in a different guy, and there's, it's a feast for lawyers. That's all it is. It's full employment for lawyers. So anyway, water coming in everywhere. I want you to pay specific attention to what's going on by these windows, because we're going to talk about that next. There you go. There's the severity of the rot. Yeah, that's not charcoal. And that's in the wall cavity. So, exactly. Bring the mold guys in. Turn them loose on it, Yeah, that's, and the OSB was replaced. This is an architect spec. Then it was covered with foam and then Tyvek again. Here's the answer. All right, in my 32 years of being in business, I've learned something. And I hope there's no window reps in here. But if you are, we can duke it out afterwards. All windows leak. I'll say it again. All windows leak. I can't tell you the amount of times that we went out and we chased leaks, tin shingles, siding, take it apart, look for everything, find nothing. Finally, you resort to water testing, which is the be-all, end-all. It takes time, but it really proves what's going on. And the windows that we were sworn to us by the rep, oh, that's impossible, that can't leak. Well, guess what? They were leaking. Now, that goes back a ways. Newer windows are better windows, newer technology, I get all that. However, better builders, and I'm not denigrating anyone, but this is cheap insurance. This is Vicor tape, again from Grace, which I love. The window gets booted, and this is a garage window. Okay, let's go to one more. Window gets booted like that, all right? Now, any leakage around those bottom corners like we saw in that ephes job can't happen because the water gets directed to the face of the Tyvek, and even though it's behind the siding, Tyvek goes all the way down, puts the water into the foundation, the OSB or foam or whatever's behind there for the substrate is fine. Now, the other thing that happens here, Dave, take me back one. When your window is set, the window will be taped. And I hope you guys are all taping your windows with Vicor tape or Tyvek tape or somebody's tape. Anybody's tape is better than no tape. But once the window is set, it'll be taped on 3 sides, not 4. So that at the bottom, if there is water in there, you haven't shut off the weeps, the weep holes, to let the water out. You not only have to think, okay, how's the water going to get in? If it does get in, how's it going to get out? And that's how. And we did not stage this. I didn't go out to the site and put this tape on. This is of the builder's own volition. And I think it's really a great thing. All right, one thing we haven't talked about, and we'll just get into this briefly. This is underneath a deck. You can see the joists up there. All right, I don't want to get in anybody's way. The Tyvek is turned back, and there's actually some foam under here. I got a better picture. Here we go. Okay, look at this. All right, it's been Tyvek'd. Bill says, hey, I put Tyvek on. I'm good. Underneath the Tyvek is the foam, right? And behind the foam is wet OSB. How'd that happen? The answer's right up here. Right up here. There's no deck flashing on the ledger board. Nothing. See it? Ledger boards need to be flashed with a Z flashing. Okay? There's multiple ways to do it. Something's better than nothing. And if you can, in your construction, if you can get the Tyvek to run continuously down the wall first and then put your ledger board on, that's wonderful. You still have to flash it. That doesn't absolve you from flashing it. You still have to flash it. Okay? So what this should look like, and I think my picture is like this. Now this is an older deck with ironwood decking on it, but if you look right there, you see that brown? That is the bottom leg of deck flashing. You have to keep in mind, and my goal here was just to leave you with like 2 or 3 main things that you walk out of here with that you remember. Anything on the side of the building that's to the weather, that's horizontal, which we'll get to in a minute. You got a band board, you got a kickboard, whatever it is. If you have brackets that stick out from underneath the faceboard, that all has to be flashed. That all has to be flashed. The water will sit on top of there, and in about 5 years it'll be punky, in 7 years it'll be black, in 10 years it'll be gone. I'll show you just some more of examples of this. This is an arts and crafts style house. See this right here? That's a Z flashing. Another one over here on this band board. Now this particular house has a different architectural arts and crafts window treatment. It's this side and shoulder treatment right here. Okay? Those shoulders stick out past what a normal window bucking would be. Okay? You're presenting a horizontal surface to the sun. It needs to be flashed. And it's not expensive to do. Here's another example. See? Flashing all along there. Flashing on the brick sill. Flashing down on the top of this lower window. Note that along the lower window, the siding is not touching the flashing. You need a drip line. You need a drip line. You need a place for the water to go. Here. Note that even the light block is flashed on top. And the flashing doesn't just stop at the end. The flashing is actually folded over the side so the water has to come around the corner and down. Band board, flashed again. This is what we call best practice. Here we go with that shoulder detail again, flashed all the way under the window because that 2x cedar is much deeper than that window. And if you didn't flash that, even though when you do something like that, the back of the flashing has to be cut away so you can slip it in there. Back me up, Dave. There we go. Thank you. Even the block for electricity is flashed. Everything. If you're going to do it, be thorough. All horizontal surfaces need to be flashed. So, recap. Ice and water shield. Not just for ice. Great way to solve flashing issues on your roof. If you're flashing skylights, you're putting in things. Some plumbing flashings come with a little narrow flange on the side. That's not enough. You can make that bigger by adding ice and water shield. Then there's the original purpose for it, which is ice. And like I said, we could do a whole day on ice. We just kind of skimmed over it. Drainage plane, think, where's the water going to go? You need to keep the house dry. So we want to make sure that this isn't you, and this isn't you. That's you. Thank you.